Hello everyone, this is Muhammad Javed. It's my lesson number 6 about the number system, and today the topic is Introduction to Complex Numbers. Before going to complex number, let me take you to the history of number system and let us discuss how we needed the number system and how we started from natural numbers and by proceeding to whole number, integers, rational, irrational, and then we move to the complex number system. So let's start with the natural number. In the start of the number system, we simply needed a system which we can use to count the things. For example, if we want to count the coins in a bag, then how we can count them? So we needed a system to count them. So first we made a system in which we can count from 1, 2, 3, 1, 2, 3, and it goes up to infinity. So we named this system as natural number system. With the help of this natural system, we solved many problems, but with the passage of time, we found a problem. For example, like if we want to find 5 minus 5, what would be the answer of this? We see that we cannot find its solution in natural number, so we needed a new number here. So that's why we generated a new number system which is called the whole number system. 5 minus 5 is equal to 0. 0 is not a part of natural number, so we made a whole number system which starts from 0, 1, 2, 3, and it goes up to infinity. Another thing, if we want to solve the equations, then how these systems help us. For example, if we want to solve x minus 1 is equal to 0, when we solve this, we find out that x is equal to 1. X is equal to 1. 1 is a natural number. So natural number helps us to find out the solution of x. Similarly, if we have our equations in the form of like x plus 1 is equal to 0, so when we will solve this, we will see that the answer is x is equal to minus 1. Minus 1 is not a part of whole number, it is also not a part of natural number. So here we needed a new number system and we generated integers. Integers are all negative numbers minus infinity to 0, and then all positive numbers to infinity. After the passage of time, we reached at a position where we got an equation like this. 2x minus 1 is equal to 0. If we want to find the value of x, then we can't take the help of natural number, whole number, or integers. So we can see that x is equal to 1 by 2. So here we made a new number system which is the rationals. Rationals are the numbers which can be written in the form of p over q, where q is not equal to 0. Okay. Similarly, with the passage of time, we found another problem like x squared plus 2 is equal to 0. So when we solve this, we find that x is equal to under root of 2. This is not a part of rational number. This is a new number system. So we named this number system as irrational number system. Okay. So when we reached at irrational number system, we finally said that the sum of rational and irrational numbers is called real number system. So this is how we completed the journey of real number system. But still our journey is not ended. When we proceed further, we found an equation like this. X squared plus 1 is equal to 0. If we try to solve this equation, we finally reach that x squared is equal to minus 1 and x is equal to minus 1 under root. Now this is a problem for us because minus 1 square root, we can't solve this, and its solution is not in real number system. Okay, let me ask you some questions like, is there any number that if we take the square of this number and we get a negative real number? Or is there any number that if we multiply it with itself and we get a negative real number? So let's try finding out such a number. If you multiply 5 with 5 multiplied by 5, the answer is 25. This is a real number, positive real number. Okay. And if we multiply two negative numbers, -3 multiplied by -3, the answer is 9. This is also a positive real number. This one also positive real number. Similarly, if you multiply minus square root of 2 with minus square root of 2, the answer is 2. This is also a positive real number. So with the help of real number system, we can't solve these questions. First one is x square plus 1 is equal to 0, and the other one is that we take the square of any number and we get a negative real number. So these are two problems which we can't solve with the help of a real number system. So this was the reason that we made a new number system which was called the complex number system. If we take a look at the numbers like square root of -16, we will see that we can write it as square root of -1, and square root of 16. You can also write it as -1 under root multiplied by 4. We can solve the square root of 16, but we cannot solve the square root of -1. This is a new number for us. To solve this new number, scientists worked a lot for many years, but in 18th century, a scientist finally decided to denote this number by iota. Iota is equal to -1 under root. So in this way, we can write -16 under root as 4 iota. Similarly, if we try to solve -25 square root, we can write it as -1 square root multiplied by 25 square root, and we can write it as 5 iota. Similarly, if we find a number which is not a perfect square root, then we can also solve it with the help of an imaginary number. We can also write it as -1 square root and 5 square root. -1 is square root is iota, and this is 5. So we can write it as under root of 5 iota. Similarly, if we solve this, we can write it as -1 square root, and 121 square root is equal to 11, and 49 square root is equal to 7. So we can write it as 11 by 7 iota. So finally, we found that any number in the form of iota is called an imaginary number. We can write all these numbers in the form of b iota b, where b is a real number and this is iota, or we can write it as unit imaginary number. If we work more on this symbol, we will find out that iota is a very interesting number. For example, iota power 1 is equal to iota. But if we take the iota square means -1 square root and its square. So when we will take the square root and square will cancel out each other, and we will get that iota square is equal to -1. When we proceed and we take the iota power 3, we can write it as iota power 2 multiplied by iota. Iota power 2 is equal to -1, and iota is as like iota, so we can write it as minus iota. If we proceed further and we try to solve iota power 4, we can write it as iota square multiplied by iota square. Iota square is equal to -1. -1 multiplied by -1 is equal to 1. If we further try to solve this, we will see that after 4 powers, the iota will start repeating its values. For example, if we solve iota power 5, we can write it as iota power 4 dot iota power 1. How we can write it like this? We know that by the formula of multiplication, if we have a number like iota power m cross n, m multiplied by n, we can write it as iota power m multiplied by iota power n. If we have a number like iota power m plus n, we can write it as iota power m dot iota power n. For example, iota power 5, we can write it as iota power 4 plus 1, and we can also write it as iota power 4 dot iota power 1. Okay, so this is how we can write iota power 5 is equal to iota power 4 dot iota, and iota power 4 is equal to 1, so we simply get iota. Similarly, if we write iota power 6 and try to solve it, we can see that we can write it as iota power 4 dot iota power 2. Iota power 4 is equal to 1, and we will simply get iota square, which is equal to -1. So we can see that iota minus 1 minus iota 1, and after 4 values it starts repeating itself, and we will get iota this one, then -1 like this, then minus iota, iota power 3, then 1, and this is iota power 4. If we add these 4 powers of iota, we can see that iota power 1 plus iota square plus iota cube plus iota power 4. Iota power 1 is iota, iota square is equal to -1, iota cube is equal to minus iota, iota power 4 is equal to +1. Here we can see this is plus iota minus iota, these will cancel out, -1 plus 1 cancel out, and the answer is 0. This is very interesting fact about these 4 powers. So we can see that if we add 4 consecutive powers of iota, then we will get 0. Here we can see that iota is revolving in a circle after its 4th power. This is iota 1, iota square, iota power 3, iota power 4, and we will and when we will take the iota power 5, we will again get iota. Okay, so this will start revolving in a circle and will continue revolving in. So far we have studied the imaginary number, but if we find any number like 7 plus I3, here we can see that this is imaginary part and this is real part. So when we get a number which is a mixture of real part and imaginary, a mixture of real number and imaginary number is called a complex number. So this is the general concept of complex number. Here I have also written as real number plus imaginary number is equal to complex number. And a very important thing which has to be noted is that imaginary number is an ordered pair, mean to say z is equal to a plus iota b. We cannot write it as z is equal to b plus iota a. These can be equal or cannot be equal, but for our a plus iota b is not equal to b plus iota a. So this point has to be noted that complex numbers are the ordered pair. Now if we take a as a 0, if a is equal to 0, then we will get z is equal to iota b. So in this form, complex number is purely imaginary. But if b is equal to 0, z would be equal to a plus bi could be equal to c plus di only if a is equal to c and b is equal to d. If a is not equal to c or b is not equal to d, then a plus bi can never be equal to c plus di. Let's try to solve a quadratic equation and see how complex numbers are involved in our daily life of solving the equations. We know that by using this quadratic formula we can solve many quadratic equations. So implement this formula on this equation and we see that x is equal to minus b. Okay, let me denote here what is a, what is b and what is c. The factor of x square is called a. Here factor of x square is 1, so a is 1. Okay, and the factor of b is x is called b, and here b is equal to minus 6, and the third factor, which is the factor of x power 0, is called c, and here c is equal to 10. So apply these values in quadratic formula and we will see that minus b is minus 6 and minus b would be 6 plus minus square root b square. B is minus 6 and square of minus 6 is equal to 36 minus 4. A is 1 and c is 10 divided by 2 and a is 1. So x is equal to 6 plus minus 36 minus 4 multiplied by 10, 40 divided by 2. X is equal to 6 plus minus 4 under root divided by 2. If you only know the real number system, then we cannot solve this equation further. But as we know that we have made a new number system which is called the complex number system, so we can easily solve this equation and we can get a more easy factor for the values of x. So x is equal to 6 plus minus, we can write it as square root of minus 1 dot square root of 4 divided by 2. X is equal to 6 plus minus square root of minus 1 is iota, square root of 2 is equal to 2 divided by 2. X is equal to 6 divided by 2, 3 plus minus 2 divided by 2, 1. So we will get this as our answer. X is equal to 3 plus iota, or x is equal to 3 minus iota. So here we can see that x is a complex number where 3 is real part and this is imaginary part. Let's solve another example. This is also a quadratic equation and we will solve it by using the quadratic formula. So x is equal to minus b plus minus b square minus 4ac divided by 2a. X is equal to minus b is 2, minus 2 plus minus 2 square 4 minus 4, a is 1 and c is 5. 4 multiplied by 5 divided by 2 and a is 1. x is equal to minus 2 plus minus 4 minus 20, which is equal to minus 16 divided by 2. X is equal to minus 2 plus minus 4 iota divided by 2. Now as you know what is how we can solve it, so I have directly written it as 4 iota. X is equal to 2 divided by 2 minus 1 plus minus 2 iota. X is equal to minus 1 plus 2 iota, or x is equal to minus 1 minus 2 iota. So this was all about the complex number, and I hope you liked this video. So subscribe my channel to watch more amazing videos about the math.